We are recording. Okay, good. So tonight we're going to go over the calibration sequences for shear wave using the IIW block. Okay. Okay, and all this is for shear wave. Okay. So when we're doing this, there are 4 steps that we have to complete to do this calibration. Step number 1 is beam index point. BIP or BIP for short. Okay. Step number 2 is the wedge angle. Wedge angle verification. So right here I'm going to stop because I think these 2 things, I know, they're tied to one item, okay? They're tied to the wedge, okay? These are related to the piece of equipment that we're going to use that allows us to introduce a specific angle into that material, okay? So what I'm talking about is I'm talking about a wedge, this piece of acrylic that we attach our transducer to, okay? This transducer gets attached to this piece of acrylic. This piece of acrylic has some information on it that we're gonna verify, okay? The first piece here, the BIP, is related to this point right here. The beam index point. Okay, so this item is described with a line, and it's your job to verify the angle is correct or it's where it's supposed to be. So what we typically do is we'll end up putting a piece of Scotch tape or something on the side of this, and we'll just mark it to verify. You know, if it's 100% where it is, there's allowances to give it a couple of degrees off, and that's okay too. But that's why we want to measure this to make sure it's correct. What happens over time is this will wear out because this piece of acrylic isn't consumable. As you scrub it in the pipe, it will shorten, it will change its thickness. As it changes the thickness, it changes the index point, okay? And with that change, you also get a change of angle. It's like in this case, if this is supposed to be a 60-degree wedge, which is the angle of incidence into the material, we're just trying to verify this angle is in fact 60 degrees, okay? So at this point of our steps, you've only verified that the piece of acrylic is good enough to use, okay? It's not worn out, it's fine. Okay. The next step kind of resembles what you've done in the past when it comes to straight beam inspection. Straight beam calibration, we're taking a thick and a thin value, which is pretty straightforward, right? Straight beam right on the step wedge, and done that. In this case, on the IIW block, we hit a radius surface and we can calibrate our distance here. Better yet, I say calibration, but realistically, verification step. We're not making any adjustments to the equipment, we're just validating, verifying that the distance that we're trying to achieve is actually correct. And as a part of that, the other way to characterize that is we're looking at horizontal linearity, okay? So like it is, you thick it thin. We know that when we have our unit or instrument on the screen, this value from left to right is a unit of time and distance. And that's all we're doing, is we're verifying it based on this angle that we have the correct distance, and we set our instrument up and we know it's correct. So when we go later on and take measurements on the weld, we can trust those numbers are true. The last step that we're going to do is perform a sensitivity check. Basically, this becomes more of our standardization, if you will. We're standardizing. Because as you recall, on the flat bottom hole standards, we put that transducer on the top of that standard, and we're looking for that small flat bottom hole, which becomes our reference reflector. Okay, that becomes what we're looking for. Well, in the case of this instrument here, with this block, we're going to establish this on the side drill hole. And briefly, what that looks like is, on the other side of this IIW block, we have, you'll see an acrylic, about 2-inch circle here, and a small side drill hole here. And what we're doing is we're going to establish sensitivity on that small reflector. And that will become what we consider to be the rejectable flaw. Okay?